Hey guys, Miss Miklos here, and I'm bringing you the first lecture of the year, and hopefully it is an easy one and it brings back some fond memories from Algebra 2 Trig. So our first lesson is just going to be algebra review. So we're going to go through a few different types of equations and just talk about how to go ahead and solve them. Our first example here is really bringing us back to Algebra 1, but since I doubt many of you did much math over break, it'll be a good refresher. So just a reminder that our goal here is to isolate x, and there are numerous ways we could go about doing this. I always like to keep our x's or whatever variable we're dealing with positive. I just think it makes life a little bit easier. And I'm going to go ahead and write out all my steps here. Normally I wouldn't. I think that we can adequately add things in our heads. So if you choose to not write out all these steps in your homework, that is totally fine. But I'm going to begin by adding 8x to both sides. So I have 12x plus 3 is equal to 7. And I know that I do need to still get this x all by itself, so I'm going to subtract 3 from both sides. And I have 12x is equal to 4. And x is still not isolated, so I'm going to go ahead and divide both sides by 12. And one thing that I want to point out here is that whenever we get a fractional answer, we should always reduce it as much as possible. So 4 over 12 here, I'm going to go ahead and write that, let me get my pen there, as 1/3, because I know 4 goes into 12 3 times. So x is equal to 1/3. If I really wanted to see if that worked, the nice thing about math is we can often check our answers. I could go ahead and substitute this value back into our original equation in for x and make sure that we get a true statement. Now, if you didn't feel good solving that first problem, these next few might be a little rough for you. Just kidding, I know you all felt good solving that first one. So here we have something that a lot of you guys hate, and we have a lot of fractions going on. And I personally like getting rid of fractions right away. And the way that we get rid of fractions is to multiply by the LCD. And just a reminder, LCD means the least common denominator or lowest common denominator. We'll see it both ways. But in this case, I'm going to look at 3 and 4, and I need to think, what is the smallest number that they both go into? So in this particular case, our LCD is 12. So I'm going to go ahead and multiply both sides of the equation by 12, and I'm actually going to write it as 12 over 1, because I know that I'm only multiplying the numerator by 12. I'm not doing anything with the denominator. So I'm going to go ahead and distribute this, so I get 12x over 3, which I know is 4x. And some of you guys might skip to this step right away, and that's great. When I distribute to our next term, I get 36x over 4, which is 9x. And I know I also need to multiply to the 2, and I get 24. At this point, this becomes a pretty simple equation for me to solve. And I'm going to go ahead and add together my x's, and I get 13x equals 24. And then I'm dividing both sides by 13, and I end up getting that x is equal to 24/13. Number 3, we're definitely bringing back some Algebra 2 skills here, because all of a sudden we've added this radical into the mix. And the one thing that you guys should remember from Algebra 2 is that the very first thing we always need to do is isolate the radical. And I like to keep my radical positive, so I'm actually going to move the x and the -4 over to the other side of the equation. I'm not going to write out all my steps here, and so I'm just going to add 4 and subtract x. So I have the square root of x minus 2 equals 4 minus x. Now that I've isolated my radical, I can go ahead and try and get rid of it. And I know the way to get rid of a square root is by squaring both sides of the equation, because we know whatever I do to one side of the equation, I have to do to the other side. And the big thing for us to remember here, and this comes up numerous times throughout pre-calculus, is that whenever I am squaring a binomial, that means I need to FOIL. So I'm actually going to go the extra step here. I know the square root squared cancels each other out, so I have x minus 2. And I'm going to actually write this as 4 minus x times 4 minus x. And I'm going to go ahead and FOIL this, so I would get first, which would be 4 times 4, which is 16. Outside 4 times negative x is negative 4x. Inside negative x times 4 is negative 4x. And last, negative x times negative x is x squared. Now, once again, we see something fun here because instead of having a linear equation like we did in the first two problems, this time I have a quadratic equation because of that x squared. You guys may also remember from Algebra 2 that the highest exponent, we call that the degree of the equation. That tells us how many solutions we should have. So in this case, since we have a quadratic equation, I'm thinking we should have 2 solutions. And last year, you guys learned a plethora of methods, the easiest one being factoring. We also learned how to complete the square, and we learned how to use the quadratic formula. We also learned how to square root both sides if applicable. In this case, and what I always try and do, if it's not one that I'm just going to square root, I always see if we can factor it first. So in order to factor it, I need to get it set equal to 0. And the reason why I want to set it equal to 0 is because I'm really trying to find what the x-intercept is. So that 0 is really representing the y value. So it's telling me what is the x value when y is 0. I'm also going to rewrite this, so it's going to be x squared. I have my negative 4x, which is negative 8x. And if I subtract x from that, I get minus 9x. I also need to move this negative 2 over to the other side, so when I add it, I get plus 18. And so at this point, I need to go ahead and think, what factors of 18 add up to be negative 9? And I'm going to try x minus 6 and x minus 3. I'm going to then go ahead and set both of those equal to 0 and solve these two equations independently. So I get x equals 6 and x equals 3. Now, before I can say that those are my answers, we need to go ahead and check for extraneous solutions. And sometimes extraneous solutions are formed when we raise things to a power. As I said earlier, since we had this x squared, that meant we were going to have 2 different solutions. But if we look at our first equation, our original equation, it really is a linear equation. There should only be one answer because of x to the first. So I'm thinking that one of these 2 might not work. So I'm going to go ahead and substitute them back in. When I put the 6 in, and I'm actually going to substitute it into this just because I think it's a little bit easier to work with. But I want to see, I'm going to write this off to the side here, is the square root of 6 minus 2 equal to 4 minus 6? So is the square root of 4 equal to negative 2? And I can see that that is not true, so 6 would be an extraneous solution. Okay, the reason why this is not true, I know often we think of putting plus or minus in front of the radical, but we only do that when we insert the radical. If the radical is already there, like it is in this particular case, we don't need a plus or minus in front of it. Now, when I try the other one, I'm going to do the square root of 3 minus 2 equals 4 minus 3. Because this time I'm substituting 3 in wherever there was an x. And I end up getting the square root of 1 equals 1, which is true, so 3 would be our answer. And our last example of the day, hooray, we're going to go ahead and once again I noticed that we have fractions. So just like we talked about earlier, I want to figure out what is our LCD. And in this case, for our LCD, I believe it's going to be x minus 3 times x plus 4. So I'm going to multiply everything here by x minus 3 times x plus 4 over 1. So I'm going to distribute, and I'm not going to do any multiplication yet. I'm just going to write it out because we're going to notice that some really nice things are going to happen. And in fact, I often skip this step just because I like writing it in the more condensed version that we're going to see in a moment. So bear with me as I write this all out. If I even have room here. You gotta love math problems where it's so big you don't have room on the screen. Anyways, the nice thing that we see here is that we have some factors that cancel out. So these x minus 3's cancel out. So I'm left with 2x times x plus 4. And these x plus 4's cancel out. So I'm left with negative 3 times x minus 3 equals 2 times x minus 3 times x plus 4. So in this step, we have effectively gotten rid of our fractions, and now this looks like a much easier problem to solve. We do have to do a little bit of multiplication, but we are smart and intelligent. We can figure that out. So when I distribute that 2x, I get 2x squared plus 8x. When I distribute this negative 3, I get negative 3x plus 9. And when I FOIL the x minus 3 times x plus 4, I get x squared plus x minus 12. And now I'm going to go ahead and kind of do two things at once. On the right-hand side, I'm going to distribute that 2. And on the left-hand side, I'm going to add my like terms together. So I have 2x squared plus 5x plus 9. And right away, you might be thinking, oh great, we have another quadratic equation to deal with. But when I try and get my quadratic terms, my x squared terms together, I notice that they actually cancel each other out. So I'm going to go ahead and subtract 2x from both sides, so I get 3x. And I'm going to subtract 9 from both sides, so I get minus 33. And when I divide both sides by 3, I get x equals negative 11. Now, before I know for sure that this is my answer, I need to make sure that our denominator is not equal to 0. And the reason why it cannot be equal to 0 is because we know that we cannot divide by 0. So if we look at this, the values that would possibly make it 0 would be if we had gotten 3 or if we'd gotten negative 4. Because 3 would have made this first denominator 0, negative 4 would have made this second one 0. In this case, negative 11 doesn't make either of those 0, so we can go ahead and say that that is our answer. So on your homework that corresponds with this lesson, you'll be going through and doing a lot of algebra problems similar to this. If you need extra help on anything, please make sure you come in and talk to me. Have a great rest of your day.